Yeah, if I just forget it, let the rendering take care of itself. Questions while I'm going about things that I've said already. I'll just jump to things that are interesting while my demo guide's taking. Yeah.
For etcd v3, are you guys going to publish like a Jepson set of tests against it?
So etcd v3 actually uses the same Raft implementation as etcd2. So anything that we've done for that, same. etcd2's Raft implementation obviously has got improvements, like just bug fixes and whatnot. No great rewrites. Yeah, so that's what we really kind of interested in. Beyond that, it's using bolts as the kind of storage mechanism now, as opposed to doing it all in memory and rereading it from the wall. So it's nice to have. And yeah, the biggest thing is really the fact that we can do such as gRPC has this. Yeah. Yes. So right now, the only thing that Torus is going to export, and just to preface the rest of the demo, is that it will export a block device. Right now, it's going to do that over NVD. The branch I'm on right now, I've been neck deep in SCSI for the past 2 or 3 weeks. Yeah, life choices. But between reading the SCSI spec, a reference implementation in C, and the kernel code, I've figured out that, so there's a new backend as of 4.2, I think it is. And it's made nice and fast in 4.6 for the target stack inside the Linux kernel. So as to provide you user space access and share some memory of the kernel and write entry from it, and then flag the kernel to update and move forward from the buffer. It turns out to be actually really fast and well designed. And so I wrote a Go package that makes the syscalls for you. Like, it's pure Go and you'll see that. And it's actually really fast and really nice. And it comes with a little demo app that can mount the loopback files. It does it through the whole SCSI stack and makes it really nice. And that means that we'll be able to support things like iSCSI like in the coming weeks, because we're just going to use the kernel for the NYC iSCSI stream. And then all the magic that comes on with being part of that whole stack. Why this isn't working. What version is this thing? I mean, you do like rendering. I mean, yeah, Go developers do that. Like what? Let's just continue to talk. And, well, let's let that go. I'll talk about some of the internals, and then we'll take those guys. So let's take a look at some of how this thing is organized. Right, so etcd is responsible for discovery of the other pairs, coordination checkpoint. This code is all the same, right? These are all the different packages. These are all some of the packages with major interfaces. Really major interfaces. This is the word package. That's its own package. That's its own package. For what these things are. The server is going to create a file object, one of these magical file pointers I was talking about.
No.
Oh, just maybe it's a smaller.
No, I just wanted to make it small.
Oh, okay. Monitoring is in charge of keeping track of what's coming in and out. Heartbeating back to etcd. The distributed layer is the thing that kind of looks like the storage layer that actually goes out and talks to our gRPC to the other nodes. Knows where everything lives, keeps track of rebalancing, so it runs through its local stores and make sure everything's up to date. And also does GC while it does that, because Torus, as you mentioned, is append-only. I just basically said it's an append-only database, right? I'm going to rewrite the value, which happens to be a block in the middle of a file, and write a new block where I can fix the metadata in etcd, and then garbage collect over time. So that's kind of the general idea of that. I'll show that in another slide. And then the storage is just to like raw, here's my memory map file, it's this big, write a block, give me a block, that's it.
Barak, I don't mean
Yeah.
to delay you.
No, go ahead.
I know the story test I'm trying to follow. How
Yeah.
do you actually use this? You say it doesn't expose a file system, it exposes a volume, and then you create a file system on top of that?
Correct.
Could you provide an example of a use case?
Um,
How to install it?
Because I show you exactly. Okay, can you see? Hopefully I'll finish shortly and then we'll be able to just go on. A client, though, nicely, is actually that's a little bit of a question. Same code, server, checks in with etcd, finds the other peers, knows how to copy them, does its own local GC, and even though there's nothing inside of it GC, there's some rebalancing, which could be useful if you want to think of storage as a local cache that I want to just write locally but then copy out over time. But mostly it's getting a lot of data from the distributed and the gRPC peer-to-peer connections. On top of that, you layer, because it has these file pointers and doesn't know quite what they are, it talks to etcd and says, okay, here's the current state of this volume. And then it can load the appropriate pointer and present the abstraction. And then it gives you a read writer abstraction, just like you expect to go, to, well, right now we're going to be pseudo custodian and locking and all the things you might want to do to the volume from a launching. Inside of the file, and this is one of these magical file pointers, which could both be a block device equivalent, or in the future, like an objects file, right? Like if you think of this as an object store, like a weird hash on S3 or something like that, that it's one of these, and this thing modifies over time. The iNode replaces and then having a bunch of, at the bottom, references to the blocks. These are the current IDs of the things individually written about. Each of these things can have a CRC check with some extra metadata, like the CRC value for each of these blocks. Read Solomon coding, so I can take a set of a couple blocks and have another block that sits off to the side that's going to be able to recreate other blocks, doing kind of like a parity check maybe, or like being able to rebuild blocks based on the existence of other ones. Encryption, I can encrypt every block the same way. So being able to layer these things on means that we can actually, and we can do it per file. So that doesn't mean like you have to choose this ahead of time. It's just, per version of the file, you can choose what you'd like to have as these extra features that people often ask about. Like, how do you know things are consistent? Well, we're CRC checking every block as we give it to you. And if we fail the CRC check, we can rebuild the block from the read Solomon encoding. But if you don't need read Solomon, if this is something you don't care about, then just don't turn it on, right? So, and then as we sync a file, right? Sync is the magic thing that takes us from version 1 to version 2. Instead of etcd, all etcd knows is you want version 1 or you want version 2, and that number has to be consistent. And by tracking that number, you can find when you're in like a weird merge condition, if the number you pulled and the one number you are now writing to is different, we can actually then start to apply some interesting logic around, like, oh, if it's an append-only file, then I can just append my stuff as opposed to trying to rewrite it. Or I can come up with interesting or volume-specific ways of talking about how things might be taken care of. Each block reference references some data, and then it's basically mark and sweep, right? And this new blue one comes in, points to this data over here, then this one that was replaced can now be GC'd if it wants to be. But if I've taken a snapshot of day1, it doesn't have to be. I can actually save it. So as long as I have enough references to the data, I'm set. Where data lives is all done through a hash ring. And so that's also where the name Torus comes from, is it's the volume plus a ring. Yeah. And so a block there for a reference to whatever block you've written comes in, and we tell you where it lives. And this function is stored in etcd, and is pulled down by every node, and therefore it can compute where everything lives. That's pretty standard for these sorts of things. One thing that's interesting that's kind of a coming notion is that this is a full permutation of all nodes in the Torus cluster. Because it's a full permutation, we can then start talking about order-preserving merge functions that will take things like, I have a list of racks in order of where I want this thing to live, and I have a list of nodes, and I can reorder the list of nodes by the list of racks and get rack awareness. Or similarly with like regions or other sorts of things that you might want. So there's a lot of thinking around that is still kind of forthcoming. But yeah, choosing to do it that way makes for a kind of nice abstraction. And then as nodes come and go from the cluster, you add a node, say in this case, the real important thing, and the reason these are highlighted is because of the next slide, which is where do things actually live? So a block comes in, a block hashes out to these locations with replication level 2, therefore it should live on those first 2 nodes, and say it gets written there. They suddenly have it, they're read. We want to rebalance the cluster. We want to do it automatically. So we add node 5 to the ring, just to the function. That's sufficient. Because then both nodes know, okay, here's the new function for this block. Applications levels 2. Node 4 sees, oh, well, node 5 doesn't have it. Checks, actually talks to the network and says, here's a list of things I have that you should have. Do you have them? No, I don't have that block. Cool. I'm going to copy it to you, because you're ahead of me on that list. And then once I've checked again that everybody has it, and my replication level is 2, well, I have something I don't need, and everybody said they have it. So then I can just clear it. And then, boom, every balance. I've gone from 2 nodes having it to 2 nodes having it over a time. And this is happening on every node all the time. So it doesn't require consistent going through etcd to do it. etcd had to tell them the new function, and the function had to be here. But based on that, we can do the right thing. One notion in this that I was going to call out, I just totally forgot. Sorry. Questions while I'm thinking about it. That's a bit of the cool part.
So
Yeah.
do you need to keep all the state on the nodes?
We need to keep the state of the nodes, not every block. Every block will tell us what nodes it lives in. We do need to keep that list of nodes. So it's the size of the number of nodes in the cluster, not the size of the number of blocks in the cluster.
But, okay.
Other questions? Because rebalancing is kind of fun. It's just, how do we go about doing a thing that's really complicated but can be done slowly? Oh, and that's the thing, is that during the process, a reader comes along and it says, I want to read something while you're rebalancing. Where does it live? Well, if it's on node 2, that's great, but what if I got it placed in the front of the line? Well, then I just go down the line. What if node 2 is down? I just go down the line. The algorithm for retrieval is actually very, very simple. Just start there and go here. We could get more complicated. We could say, oh, well, I know I'm in this rack, so try that one first, because it's going to be closer to me, right, for speed purposes. But ultimately, it just goes down the line. Which is so, and then if you've lost enough nodes such that you don't have the block, you've lost enough nodes such that you don't have the block. You're kind of in a really bad failure day at that point. Or you may be under a network split. This means that your reads individually will start saying, sorry, I'm failing. But it also means that your data is okay, provided you repair the split. It also means that things like writes will start to say, I can't write to these things. So basically it kind of shuts down to like whatever you had last. It kind of fails more safe than open. Let's see if everything's going. What is going on? Oh, it wants a username and password for this. Why? Whatever. Can you build now? That'd be great. I think it's
Remind me of a very basic question again from someone that is not from storage.
Yeah, totally.
If you're doing the replication and you're checking at the volume level, that means does it make sense to put this with a file system account, like HDFS or something like that, if you're already doing it at the volume level?
So each of those things is happening on a block level, like individual parts of a file. So then the abstract notion of file, the whole metadata, the CRCs, everything, is also a block unto itself that lives somewhere. And then etcd keeps track of the pointers, which is what version number should I look for, and then I can put together the key that I need to go find. Running a distributed, so like a distributed more object store, kind of like an HDFS, that would be etcd saying, I have this list of version numbers in my head. Here's where they are, and then associated with these file names. Like a very simple object store would look like that. And based on that, when I update an object, I update that key in etcd. Slower, because it's updating the key, but it's not writing everything, it's just writing the fact that I updated it at the very last moment. And until then, all the other readers, all the other writers see the old version of it, they're fine, and then they see the new one. So, hey, compiled. All right, this one actually has the cool bit too, I think. See how much the demo gods hate me. So I'm going to run 3 Torus nodes. It should just work. They did just work. Good. Still all running, and down here, I can run Torus pedal list peer list. Sorry, it's always the thing. Boom. They're all reporting in. And this is updating every 5 seconds or so. They all 5 gigabytes of. In fact, let me move this over so it's darker behind me or something. Yeah, it's easier. 5 gigabytes. They're all members of the ring. They're not just available, they're actually members. They were updated 4 seconds ago, keep updating. That's where they are. That's where they are currently reporting in from. The UUID is the only thing that really is important for where the data actually lives. So if you move a disk or if you move data around, as long as it's just reporting in with the UUID, you're fine. Yeah, so that's kind of what you see as things kind of go along. Now let's do the interesting part, which is, I'm going to do it, I'm feeling lucky. If this works. So I have to be root to do what I'm about to do now, which is to say I want to actually create a device on the file system that is going to represent, first I have to create the, I have to list the nodes. I'll show you what it looks like. So volume list. Did etcd died, what the hell? That's a bug that I didn't create. Start from the top. Yeah, at least I know why. Pin all deletes pin, that's what happened. Which is the right thing. But, okay. And that's because I wanted to delete it to do stuff. Oh wow. And Nate cleared it. So etcd lost its data directory. I'm an idiot. That's all that's happened there. Well, fucking my script deleting my stuff on under me, right? That's really the test. There you go. The setup script also creates a volume. And I can go back to peer listing. Cool. So yeah, volume list. What is the major non-adjustment? Alright, let's go to plan B. This may just be my branch for all I know. I'd have to pay etcd anyway. The demo gods are not with me. I'm feeling really silly right now. Okay. Volume list, peer list. Okay. We're there this time. Hopefully. Right. Volume's there. I created it. It's a block volume. It's 5 gigabytes in size. Replication level is 2. I can get that from ring-git. Should tell me some details. Replication level is 2. The peers involved. The UUIDs. Oh, there's a bug in etcd, isn't there? Something's wrong. So I'll have to open that message. Sometimes trusting etcd is a problem. Of course, they just come out with a new version, so.
Should we tweet that? I was just
It is being recorded.
It is true.
Yeah. Thing that bugs bugs happen, right? Like, this is not part of, this is just life.
Is that stable or bleeding edge?
That one was actually bleeding edge. That one is one I built from like months ago. Let's just grab stable, because that's probably a good idea.
So you're setting the replication level of the volume?
Of the entire cluster.
Okay.
Now, individual volumes could have another layer which keeps another copy of a block somewhere on top of this, but they need not. The replication level of the volume of the cluster is just paramount. That tells you what your base expectancy is like. I can lose 2 nodes, or 1 node, or however many.
That also has impacts on how much you can store. So like, if you have 15 gigs between the 3, you
Yes.
should have like, what, 7 point something or what?
15 gigs between the 3, replication level 2 means I have 10 gigs, because we need, or sorry, you're right, 7.5. Delivery block we are at this, it's 7.5. And then, if I'm really lucky, especially lucky, so I'll start to check in, but I don't trust that. So, ha, okay, cool. Hopefully this time SCD won't fall over. Of course, like I said, that was a very, somewhere in the process of 3 being developed branch. Had enough of a new API, but not enough of a stable one. Still there? Still happy? Okay, let's go for it. So, right, I am going to mount block vol, the volume is 5 gigabytes, as TCMU block vol. TCMU is the new function I'm just creating. Okay, my demo's shot. I can do the other one, I guess. I'll show you what it looks like in Kubernetes. This is the Kubernetes meetup. Let's just go, like,
Can you explain a little bit how it would fit the full stack in Kubernetes?
Right,
How
so-
Kubernetes eventually use the Torus volume.
so what you see if this were working is that I would run one more command, Torus block TCMU or something, mount equivalent, of the volume, and that would create dev Torus block vol, which I would format, ext4, whatever I want. It just shows up as a new block device that can be mounted. That looks a lot like a persistent volume for Kubernetes.
That the Kubernetes nodes could mount, or that the Kubernetes?
That Kubernetes can learn from that. So Kubernetes would need to run the tool to connect to etcd, connect to storage nodes, and connect to the kernel, so that it could then mount it and then provide the storage to the container. But Kubernetes tells you where and how to mount it through flex volumes, which were added in 1.2. Because of this,
A volume for each one of the nodes in the Kubernetes cluster, right?
you need a volume for each application. But the node, but the volume exists in a kind of magical state across the cluster. Right? I can just mount it in any particular location.
Right.
So any node in the Kubernetes cluster could mount it.
But no, it's not shared. No?
But not shared, yeah. Not shared at the time, at this moment, at the time. We're working right now on like block storage. So it's attached to one device, but it's not. Yeah.
So in like an optimal setup, would you actually be running a like a Torus daemon on each node?
Yes. In fact, that's what I'm about to do. What is it? Git nodes, sorry. There you go. I have a little packet cluster going, if you recognize those IPs, which I've gotten very, very familiar with. And I have in contrib a Torus Gates one-shot. Let's take a look at that. Sets up etcd, Torus service sets up the, let me make it easier to read. There we go, yeah, that's better. Sets up the etcd Torus service, sets up the, goes to play for etcd, puts it on a node somewhere. This is not how you should run etcd in production, by the way, it's just running as a on a single node inside the Kubernetes cluster. But you can imagine replacing this with a script that actually runs etcd in a real way or running it on the side or whatever you like to do. Then there's a Torus daemon set running on every node in the cluster, which pulls again from Quay, latest, runs the same commands, debugging it, auto join, so it'll add itself to the ring when it comes up, using amount pointed data and local data serve Torus on the host. I haven't tried this on this particular Kubernetes cluster right now, but here we go. Create. That seems to have worked. Yeah, okay. I'm running a little Torus cluster on my Kubernetes. 5-node Kubernetes cluster. They're coming there. I think they're pulling down right now. And if I'm right, and if I've exposed the right port, have I exposed the right port? I think I made it a.
40,000?
Yeah. Oh, 323979. There it is. So, yeah, if I connect to any of them, in theory. Okay, this one. And run my local, bin, Torus fiddle, -c, IP, 332.379. CoreOS. Oh. Okay, they just haven't come up yet. That's fine. Yeah.
Could you show me the YAML file real quick?
Yeah, you want some info? Let me do that. So, what part of it? That's etcd creation? Yeah. So, yeah, here's the etcd service for etcd client port 230.279, node port 32.379. The internal one is so that inside the cluster we know where it lives. It has a static IP for that service. That's what I did that for. And that'll become relevant in a second. It's actually not needed for any of the rest of the stuff here, but it'll become really useful in a second. And then setting up etcd, data directory, clusters, and it's one node cluster, and then Torus. Sorry. That's promising. Boom. Okay, I'm a little bit happy with that. And it's also using the internal IPv for the packet. So, okay, cool. And there's 5 nodes, they're all checking in, they all seem to be healthy, etcd hopefully isn't falling over. The 5 minutes from now is because my laptop's clock is skewed because of sleep and Linux. So now we can do, let's see, volume list, there shouldn't be any. Volume, okay, create block. Say, let's call this PG1 and make it 2 gigabytes. Cool, I have a new 2 gigabyte magical block device out in the cluster. Now what's really cool is, if I'm right again, I have this Postgres run shot, which is going to run Postgres with the port, node port, and it's going to set everything up. And here's the very interesting part. Here's what some of you really were asking me about earlier, which is how does it actually go about doing this? So here's a volume definition for Torus. I actually have preset up the Torus mount tool as for the flex volumes. So as the data flex volume type, driver is given this, which means it's going to look in a particular folder, which is set by a particular flag on the kubelet, and then execute that binary name, Torus under the folder CoreOS.com tilde Torus, and then pass in the rest of this as JSON on the command line. That's what it does. It's got a pretty simple API. It just hands you some command line stuff, and you respond on standard out. That's all you have to do. But once you do it, you tell it, okay, I mounted it, here's the device. And okay, you want me to mount that device on this port path, I'll mount it here. And that's...
So when you say that, you spoke earlier about shared, you said you're not yet shared, and you said you can attach an application to run volume now, right?
Mm-hmm.
can you attach multiple applications to the same one?
Not right now, and never read writes for blocked volume.
Oh,
There's an open bug for multiple read volumes, for instance, that would make some sense for having like a configuration volume that I just want to mount in,
okay.
or something like that, right? Or, and possibly a one writer, multiple reader one. But yeah, nobody's writing much at the same time. As we get toward object stores and interesting things like that, things where the actual file system semantics will go through etcd, so we can provide a consistent view of the world to everybody, then we can have multiple readers, multiple writers.
So right now, if I have a cluster with five nodes, I can run 5 applications in a cluster.
You can run as many applications as you want.
Oh.
It's just that each volume will be attached to exactly one of them.
Oh, okay.
Yeah.
Do you have hooks for recovery logic, either on the application level or on the file system level?
In what sense? Recovery and such that?
Like, let's say that you either need to fsec or maybe use some Postgres recovery tools if the database crashed or if there were some kind of forcible on that.
I see. No, I also don't know if that's exposed within the Flux Volume API. I know they're adding stuff to that and kind of re-envisioning that. You're right, it would be nice to know if something failed in that sense and be able to take action. As far as through the Torus API, if you're building a volume type, you can obviously, it's just errors, right? You just check them. But, yeah, so as it pertains, like, how do you expose that, right? And that comes out through, well, how would Kubernetes expose that? Well, okay, not sure, but that's, it would have to go through Flux Volume somehow.
So is that actually formatting that volume on mount, or is it just kind of saying, oh, I'm going to talk to this thing as ext4?
It will, so I've written the logic so it will format it on mount if it's not already formatted. But it'll check, it'll actually check the thing, see if the headers or any headers for any sort of file system are there. If not, I'll format it ext4. If it is, I'll error out and say, no, I'm sorry, you're telling me something crazy.
Is there any like logic to not let you like change the file system type and then accidentally like write over something that's already there, or is that kind of?
It just won't let me.
Oh, okay.
Yeah, once it's been formatted, it's never going to be formatted again.
Okay.
It's just going to like, that's not ext4. Right. What are you doing, right? If you want to, you can actually then delete the volume or change or mount it externally or use the Torus fiddle to fix your world. But yeah. And the reason I called it PG1 is because in this PG1, the reason why I had that magical static IC inside of the Kubernetes cluster was so that I could tell that the mount tool where to find the other things. I could actually use a service thing that's a little bit weird right now with the way that Hypercube and not Rocket, but we're running the kubelet under Rocket on CoreOS that does some things. So it's like one of these things isn't working such that that I should be able to write, Torus.Kubernetes.discovery, whatever it is, right? But instead I just do this. But that's all it really needs, is these couple things. Where to find etcd, the volume name that we created, and other things that are pertinent to like the ext4 or whatever. It defaults to ext4, just pull it out. And so if I'm right, then I should just be able to kubectl create Postgres. And if I'm right, number 2, I can connect to that port with a PSQL. I think it's Postgres. Postgres foo, I forget I did that. I think it's in the one shot. Test Torus. Yep, there it is. So PSQL -u Postgres to IP and 3432. If it's running, host, I need to do -h and -p. PSQL, other commands for that. Lowercase h, lowercase p, capital E. Cool. Is it up yet? questions while they come up, pull down from the world. And the next step in this, by the way, is to like write some data, cordon off a node, so it reschedules, and should just reschedule. My data should still be there. Which when you think about it, it's kind of like that's the problem we're trying to solve with Kubernetes, right? Is the data should just live on the cluster and be self-sufficient. So, yeah.
Is there any priority when rebalancing data?
Not at the moment, but that goes to the same notion of saying I have multiple functions, I might be able to preserve order and merge them. So if you want to say there's priority in the sense that like if I have a 100 gigabyte thing and two gigabyte things, it'll do the right.
Let's say you have a file, something that is replicated 3 times, and maybe something is like there are 2 chunks missing from one, and then another one is only missing one. So one is more a danger than the other.
Yeah.
Right. So is there any prioritization?
Not this time. There's a balance between doing everything I can. Like I was unable to check this one time, so I must copy it somewhere else, which is very good and like preserves a lot of things very well in that case. In which case it would just go down further down the line. So if you had 5 nodes and the third one had 1 left, it would just copy it to the other 2, figuring, hey, they may be gone forever. I don't know. Of course, that causes a lot of traffic the minute you have any sort of error, right? So it's how error sensitive do you want to be versus how often do you experience errors.
Yeah, because, I mean, there might be data that is more at risk than other. So
Yeah, and so there's no priority in that sense then, no, because they just look like blocks otherwise. But yeah, that is a sort of interesting question. And also, could I say things like, I want more replicas for this particular volume?
right.
Because it's more sensitive to me for it. It's my database, right? Of course, this takes forever. Meanwhile, I will pull up the guide I haven't run through before on running the coordinate. Yeah, that's it. What is it? Details. Describe. I just did it. Right? Oh, well, okay, didn't work. Because I failed it somehow. Service already exists. Sadness. The gods are not with me tonight. I'm having the worst time.
What are you doing, like coding them off?
I'll just move along and yeah, but I'll do 5 minutes of more questions or things that are going on or more things you can explain or try. That's what you get for tempting me to my dads. Yeah,
So, mine was just general. What do you think the errors were? Like, is it?
Oh, so that was my guess. NDD doing something weird. Like, I think we just pushed new alpha like last week, and I had made announcements to the way NDD works on particular CoreOS alpha at this exact moment. I'm not sure. I know that's an error that comes up a bit, especially with NBD, because if it doesn't connect correctly or something's up, then the kernel may not disconnect it correctly, and it's kind of just weird, just because the NBD driver is really crummy inside the kernel, which is why I did the whole SCSI bit, because now I want to do that. Yeah.
Stupid question.
No.
Just trying to get a bit. So let's say you create a service, you've got multiple pods, and I guess on each physical node,
Mm-hmm.
the kubelet creates a Torus pod for the master Torus service. Is that
Yeah.
correct me where I'm
Yeah, that's
wrong?
right. Yeah.
Okay, so you create a new block device. This block device is being replicated in every.
Yeah. It's actually replicated and kind of split up between each node.
Okay.
Yeah. And the data actually, it's been provisioned, right, which is to say that the data doesn't exist until it exists. And then as you overwrite it, then it will get cleaned up. So it only uses up to the amount of like 5 GB volume size, right? Times 2 for the replication, but only up to that. Yes.
So then when, oh, sorry.
No,
So
you're
then
okay.
when you create the consuming service, let's say you create your application,
Yeah.
consuming service, and it's mounting this Torus storage.
Yeah.
Your service, a pod for your service on every single node, you're saying that, you mentioned when he asked this question that only one pod could write, that's where sort of like.
So only one pod at a time. So you deploy a new application. It doesn't matter where it ends up on the cluster.
Mhm.
Mount daemon will be run for it, and then it will just kind of grab the data from the entire cluster and feed that to the pod. And then so this pod goes away, you reschedule it or something. That disconnects, gets rescheduled, reconnects, same thing. So, and because we go through etcd for consistency, right, we know that as of the last time you synced something, or at least that's the lie we're trying to tell correctly, right, is last time you said sync, we moved the pointer in etcd, so up to that point, you should be saved. And that's what most people guarantees are, so.
Sorry, one last question.
Yeah.
So what are you doing when multiple pods are trying to write to the same, do they just get like?
So they can't right now, right? Multiple pods can't write to the same, only one can mount one at a time.
Okay.
But as you reschedule things and move them around, they can follow the pod around. So the data, right now the real problem is, right, is that unless you're running something like EBS or other things that already plug into Kubernetes, which you can't run on bare metal, obviously, because you don't have an EBS server around, your storage is limited to like local or other things that are out there. There's staff and stuff too. But wouldn't it be great if you could manage all this through the infrastructure you already have on your cluster, which is etcd and Kubernetes for updates and whatnot, right? What if it were just a things, what if it were just etcd? What if it were a separate problem?
You have 10 copies, you replicate in a single pod, and you have 10 copies, you would need 10 volumes, right?
Yeah.
Or the 10 copies, you would need 10 volumes.
You need 10 volumes. You could do some fun things like, I do support like snapshots and creating volumes based on copies of copies. So, and you can take snapshots at any time and roll back to them and move on from one thing.
And do you guys have any sort of like locality concept, maybe in the roadmap, so that
On the roadmap, that's again the ordering preserving functions, right? Which is, if you define an ordering or a locality for each of these things and say, I want to prefer things to be co-located
right?
or to not co-locate, I want to make them far as away as possible because I want to make sure that they don't burn up at the same time, right? Then yeah, it's keeping those orders and doing everything. It's a really massive thought I've been kind of mulling over, which is how do I keep these two functions in? What sorts of things can I do? I can do things that are co-located, like prefer these things, that totally anti-prefer these things, that I want it to be on one on each and never again. I can do a lot of crazy sorts of things. So trying to think through that and then turning that into an API, which is just like, okay, make sure it's rack aware. Here are my, and every node has a rack ID, so it's attached to it. Just make sure it doesn't do, it does the right thing for me, right? But doing some math to actually prove that that'll work. I don't know. I think it's kind of cool idea.
Is this walkthrough in the repo? Is this walkthrough in the repo as an example?
That's just work that is being designed right now, that specific feature right there. But all of it's
No, what you just did.
Oh, yeah, that's all in the repo actually. Yeah, that's all under control Kubernetes. So, yeah, launching pods and trying that out.
Rudy, I think, wrote.
Oh, yeah, it's beta right now or alpha?
Alpha right now.
Alpha.
It's early days. I mean, we decided to do this in this particular, which is, hey, here's a really hard problem that we know people are going to give us a lot of flack about, right? Let's just get it out there now, get people to help out, people see what we're trying to do as early as possible. And it's free software, right? Like, if you don't like it, fine, but like, it's not stopping you from using what already existed. But here's the thing, is that we can even build it and show people what will exist, and we can also keep it in the public sphere longer. And that's just a better way to do software, right? And so,
Are you getting uptick in the community? With
Yeah.
anyone contributing to it?
yeah, within a couple hours, I had a first contributor from DigitalOcean, actually. We were using his ATA over Ethernet package, because we can also just, once you have a mount tool that can just kind of mount a thing, take a lock of it, and then provide it, in this case, to the kernel, but it can also provide it over the network, right? It can provide it over ISCOs, do all these things, right? It's kind of abstract at that point. So we were using his ATA over Ethernet package to provide it, to just see if we could do that sort of trick, right? And he's like, oh, you're using my package, it's awesome, let me clean that up for you. So he added a whole bunch of new features to his package and then our interaction with it. And so now it's actually fairly fun. So.
Rudy, and then we'll move on. Did you have a question? You already answered. I was going to ask if you had a copy on write, but you said you didn't.
Yeah. No, because it's append only, right? Then, and because you write a new block every time you change something, you can change it in the middle. And that block gets synced out, the pointer moves, you keep that reference. And if there's still a reference to the underlying thing, we can then go back and get it. And so the snapshot is just save those references and doesn't delete them, right? I gave them a name.
But you need to keep the state of all the snapshots across the whole etcd cluster.
You need to keep the state of the snapshots in etcd, yeah. But that's really just keeping a pointer to the version that that snapshot represents. So we're talking a couple bytes here. The length of your name and 64 bits of what version it was. So it's pretty tiny snapshot.
I was wondering how much, so you're limited by the RAM on the nodes?
No, I mean, you can even,
Or are you storing all the information about the blocks?
you're storing all the information about the blocks in the store itself.
Oh, okay.
The only thing that's kept in etcd is which block to find the blocks that find the blocks, right? It's all individual, yeah.
So 2 questions. One, any lessons learned as far as anything that you thought would be easy that turned out to be a lot harder? And number 2, what OS and window manager are you using?
Arch and i3, that's the easier question. Incidentally, side note, I thought you were going to ask, like, does it work on Windows? And actually it does, even though it's OSD on Windows. And just because it's in a file, it works anyway. I think you go. But as for lessons learned and things, I think the number one, I actually had a lesson learned in the other way, something I thought was going to be really hard, which turned out to be a lot easier, is doing the rebalancing trick. I was thinking I have to keep like a snapshot of the whole state of the world and slowly move people over and kind of be able to roll back, but it turns out actually that doing this is more, if not more resilient and way easier to get and way easier to keep track of. Just because the algorithm is, instead of saying it has to live in the first 2, it can just live on the 3rd one, and your read latency while it rebalances kind of is like, I checked this one, that's not bad. So it means that the trade-off is getting a little bit in read latency for a lot of simplicity. So that's one kind of cool thing I learned. I spent 2 weeks on the first rebalancer. I spent 5 hours on the second. So the first, like, hey, that worked. From 0 to hey, that worked. Yeah.
All right. Cool. Well, thank you very much. Appreciate it. And,
+1 for open source software.
Yeah.
yeah. And if you need a hug on the hacker stuff, hacker news stuff, I'm happy to. Next up, awesome.